Okay, this lesson is called factoring special form. So what we want to be able to do is factor quadratics that are a difference of squares and perfect squares. And both of these are like special cases of factoring trinomials. So we're going to kind of be doing what we were doing in the last lesson. These are just special things to kind of be on the lookout for. Okay. So let's just refresh our memory on what we were actually doing here. A few lessons ago, we looked at expanding binomials, which meant we took our two binomials, binomial just means two terms, and we expanded these using the FOIL rule, right? Our first two terms to get x squared, our outside two terms to get negative 5x. I've already done that term. Let's do our first two terms gave us the x squared. Our outside two terms gave us the negative 5x. Our inside two terms gave us a plus 1x, and then our last two terms gave us a negative 5. So we ended up with, after we collected these like terms, x squared minus 4x minus 5. And then we were factoring a trinomial, we were doing the opposite. We were taking something that was our trinomial that we got from expanding binomials, and we wanted to write it as these two binomials multiplied by one another. And we did this by looking at, well, we knew that we had to have an x and an x to get this first term, x squared. And then we looked at what we needed to multiply together to get that last term. So we needed two numbers that would multiply to give us that positive 8 and would add together to give us that middle number, negative 6. And we would think of pairs of numbers. In this case, our numbers are negative 2 and negative 4. They would add to give us negative 6, multiply to give us positive 8. So we would get x minus 2, x minus 4. Okay. And you can see the note up at the top. Why are we doing this? Because this trinomial that we have over here, and then this trinomial that we started with up here, we can see the x squared. These are quadratic relations that we've been working with all along. Okay. A special case of expanding binomials comes when we have something that looks like this, x minus 5 times x plus 5. So what happens when we apply the FOIL rule here? X times x gets us x squared, x times positive 5 gets us plus 5x, negative 5 times x gets us negative 5x, negative 5 times positive 5 gives us negative 25. We collect our like terms, we get x squared plus 5 minus 5 cancels out. So we don't have anything here in the middle, and we're just going to have negative 25. Okay? This is called, you can see right there, a difference of squares. And the difference, we call it a difference because we're subtracting two things, and it's a difference of squares because this first term here is x squared, and this second term here, 25, is 5 squared. So it's something squared minus something else squared. And that's going to happen every time we see this pattern where we've got the same terms in our brackets, just with, like that term is the same as that term, with the opposite sign in between them. If we were to go ahead and expand this one, 2x times 2x gives us 4x squared. 2x times negative 3, negative 6x. 3 times 2x gives us positive 6x. And 3 times negative 3 gives us negative 9. Then when we collect our like terms, again, 4x squared, the negative 6x and the positive 6x cancel. 4x squared minus 9. This is our difference of squares. We're subtracting two things. Our first thing is 2x squared, and our second thing is 3 squared. Okay? So being able to recognize this pattern can save you a bit of time if you're doing some factoring. All right? So if we have something that looks like a difference of squares, like we see here, a squared minus b squared, we know that this is going to factor to something that looks like this. We're going to have a here and a here, b here and b here, and then a positive sign in one and a positive sign in the other. Okay. So if we look at the second one here, x squared minus 4, and we think about what we're going to have here, we can think of this as, our first is x squared. Our second one here is 2 squared. Right? So we're going to have x plus 2, x minus 2. Now, if you don't happen to see that pattern, okay, you've gotten good in the last lesson at factoring trinomials. We can take this thing, this x squared plus minus 4, and we can write it as a trinomial by adding that missing term that's in the middle. Like we're used to having 3 terms in our trinomial, an x squared, an x, and then a number term. What if we put in a term there that has a 0x? And let's try factoring this as a trinomial. Well, we know we're going to have an x and an x. We know that we need 2 numbers, and those 2 numbers have to multiply to -4, and they have to add to 0, our middle term. What 2 numbers multiply to -4 and add to 0? Well, if they're going to add to 0, one of them has to be positive and one of them has to be negative, and they have to be the same number. So -2 and +2. Okay? So either recognize the pattern or add in that 0. So let's do this next one here by adding in that 0 term. I'm going to rewrite this as x squared plus 0x minus 81. And then I'm going to go ahead and factor x and x. I need 2 numbers that are going to multiply to -81 and add to 0. So what multiplies to -81? Well, it's going to be 9 and -9, or -9 and 9. So those are the terms that are going to go in there, -9 and +9. Okay. So when you see ones like these more complicated ones down here, that won't work using the technique that we just used there. So these ones here, you have to recognize the pattern. You have to think of this as 3x squared, and you have to think of this as 10 y squared squared. Then this will factor as 3x minus 10y squared, 3x plus 10y squared. Okay? But that involves recognizing that pattern. Okay? This one would work the same way. This would be 2y minus 6, 2y plus 6. Okay? Because that 4y squared is 2y squared, and that 36 is 6 squared. Okay? Now this last one here, x squared minus 64x, it looks like it could be a difference of squares, but notice we have this extra x here. So this last term is not 8x squared, or is it just 8 squared? So this is not a difference of squares. Now, we could still factor it. We can still common factor this because we have an x that is common to both terms. So this would factor to, just pulling out the x, x minus 64, just like that. And that's all we can do there. So that's a difference of squares. That's one of the special kinds that you should recognize. The other one is, again, it's even more closely related to just factoring trinomials. Let's look at what happens when we factor x squared minus 6x plus 9. We set up our 2 brackets here, x and x. We need 2 numbers that are going to multiply to +9 and add to -6. What are those 2 numbers? Well, let's see. What multiplies to 9? 1 and 9, or -1 and -9. Better candidates are -3 and -3 and +3 and +3. Which ones add to -6? These 2 right here. So we'll have x minus 3, x minus 3. Notice that those 2 numbers, or those 2 terms that we have, are now the same. We've got x minus 3, x minus 3. X minus 3 times x minus 3 is just x minus 3 squared. Okay, to write it a little bit more compactly. So this is what is called a perfect square trinomial, because when we factor it, we get something, a single thing, x minus 3 in this case, that is squared. And we can have other ones that look like this. So let's factor this one here. Let me change colors here. So we're going to factor this, x and x. We need two numbers here that are going to multiply to 25 and are going to add to positive 10. So it's positive 25. What are those two numbers going to be? They're going to be positive 5 and positive 5. So this factors to x plus 5, or x plus 5 squared. Right? So sometimes you can recognize this pattern in the same way, okay? But I say these still can be factored the same way as a regular trinomial can. So if we see something like this here, we could recognize that this is a perfect square trinomial, but we don't have to. We can just factor it as, all right, a and a. We need two numbers that multiply to 36, 6 and 6. They both have to be negative to give us the negative 12. A minus 6 squared. Okay? So try this last one here. It's a perfect square trinomial. Just factor it as a trinomial and then write it as a square. And we'll do it together. We need two numbers here that are going to multiply to positive 4 and are going to add to positive 4. Those two numbers are going to be positive 2 and positive 2. So when we put them in, we get x plus 2, x plus 2, x plus 2 squared.